Okay, today we're going to look at section 3.4 called Completing the Square. And first I'd like to begin with an example. Previously, all we've known to solve quadratics right now is to use the AC method. So if we were to take this quadratic right now, x squared plus 8x plus 10 equal to 0, we would say, well, we're going to take 1 times 10 and we're going to look for two numbers that can multiply to give me 10. But if you add them up, you're going to get 8 for the middle of the term. So you go through and you look and say, well, I know 1 times 10 is 10, but 1 plus 10 is 11. 2 times 5 is 10. 2 plus 5 is 7, so that's not working. You're thinking, well, what if I go to two negatives? Negative 1 times negative 10 is 10, but negative 1 minus 10, it gives us negative 11, so that's not going to work. And the same thing happens with negative 2 and negative 5. That adds up to give us negative 7, even though they multiply to give us 10. So you're thinking, well, how am I going to solve this? Well, let me give you a visual picture here. Now let's look at the graph of this. If we look at the graph of this function, or this quadratic, we see that it is clearly crossing the x-axis, so there has to be some type of solutions for x. But factoring is not allowing us to get there. We have to have a different method of attack, and that's where this method of completing the square comes in. And before I go in and just show you all the steps before completing the square, let's look at some kind of like the history behind this and how mathematicians looked at this using the most dominant form of mathematics way back when, which is geometry. Now, we could look at x squared, but let's think of that geometrically. Let's think of that as an actual square. What if it's got a dimensions of x by x? There may be a width of x and a height of x or a length of x, however way you want to look at it, but x times x gives us that area of x squared, so we could use this to represent x squared. Now the 8x that we had in the problem, again, we can think of that as length times width or base times height, either way you want to look at it. But we could say that maybe the top here has a length of 8, and the height of this box, or this rectangle, would be x, so that would give us an area of 8x. I'm thinking, well, what if we could take this square and this rectangle, could we add them together? Could we put these two together in a shape and we see that, hey, this is not making some type of square anymore, it's a rectangle. How could we make this, or maybe manipulate this problem in a way, or these shapes, to make a square? So the first thought is, well, what if we take the blue rectangle here, what if we just divide it in half into two equal pieces of a rectangle? And I thought, well, we can take half of it, put it vertically, the other half of it, let's put it horizontally, and let's just remind ourselves. Remember how the length of this rectangle originally was 8 before, so if we cut it in half, now we have a 4 by x rectangle here, and we have a 4 by x rectangle there. What you should notice is, hey, there is something missing in here that maybe we could put in there to make this whole shape itself an actual square. We need to find that piece right here, what I have in orange, to complete this thing into a square, and that's kind of where the method gets its name, or it is where the method gets its name. So that's just kind of some geometry and visual pictures behind where we're going with this. So without further ado, let's look at all of the steps to completing this square. And I'm going to start with x squared plus bx plus c. And I'll preface this to say that we're only going to do this completing the square when a is equal to the value of 1. If a is something else other than 1, this requires an extra step. But I'm going to say that we're going to have a method in the future that's going to work out a little bit better than that. So, first step. What I want to do is add, or maybe subtract, the c value, the constant, to the right side of the equation. Now, sometimes this is already done for us, but we want to make sure that it's over there. We want all the variables to the left side of the equal sign. Step 2, I want to divide b, the linear term, by 2. Whatever that result is, I want to square it, raised to the second power, and then I'm going to add it to the right side and the left side of this equation. Step 3, we're going to factor the left side of the equation using our AC method. We're going to create that square that is factorable. Step 4, we're going to solve for x, and we're going to use the square root property. One thing to note is that you don't want to forget that plus minus symbol when you are using the square root property, because there is a positive number that multiplies to give us our square, and there is a negative number that gives our square. And step 5, this is if you need to, if you're not 100% certain that your solutions are correct, you can always plug them back in and make sure that you're getting the correct solutions. So let's go back and look at our previous example, the one that we had at the very beginning that posed our issue. If we go through our first step, step 1, let's move C over to the right side of the equation. That's going to cause us to subtract that 10. What I will do that's kind of special here is I'm going to leave a gap between the 8x and the equal sign because I'm eventually going to put a number there. Going on to step 2, take the B number, that's the 8. We're going to cut it in half. That'll give us 4. And then I'm going to take that number 4 and I'm going to raise it to the second power, which gives us 16. That 16 I'm going to add to the left side, and because we've always got to keep our equations balanced, I'm also going to add it to the right side. Clean this up, and that gives us x squared plus 8x plus 16, and the negative 10 and the 16 together gives us 6. Now I'm able to factor this. Okay, to find two numbers that multiply to give me 16. That will, if I add them together, I'm going to get that 8 in the middle. Those two numbers are going to be 4 and 4. You're going to start to notice some patterns over the next few examples. But if we go with our grouping method, we'll replace the middle terms with those 4s. So we rewrite 8x as 4x plus 4x in the middle. We'll always solve with grouping. Now we see that the first two terms, x squared and the 4x, they have an x in common. So that leaves us with an x plus 4 in the first parentheses. We notice that 4x and 16, they have a common factor of a 4. And that will also leave us with x plus 4 in parentheses. And this is all happening while it's still equal to 6. Now we have our x and our 4 here. Those are going to be grouped together as one factor, and the x plus 4 is the other factor. We notice that we have two factors that are exactly the same. If two things are being multiplied to themselves, that means that they are being raised to the second power. And this is where the square root property is going to come into play. So I could take the square root to both sides so that the square root can cancel out the square. And what you'll see happens here is that anytime that you take a square root of a number in an equation, you want to make sure you put that plus minus symbol there. Because not only is the positive of square root of 6 times the square root of 6 equal to 6, but it's also true that negative square root of 6 times negative square root of 6 is 6 again. So you have to put that plus minus symbol there. And usually this is kind of confusing to people when they first see it. So what this is really saying is the two solutions are going to be 4 plus the square root of 6. But the other solution, and I should change that, that should be negative 4 plus 6 and negative 4 minus 6 for the solutions. And so that's where the completing the square comes in. These are the actual points where this graph is going to cross the x-axis. Let's take a look at a few more examples. Here we have an example, x squared plus 4x equal to negative 11. Now if we go with our steps here, for the first step, it's already done for us. That constant number has already been moved over to the right side of the equal sign, so we don't need to worry about moving it. But what I am going to do is I'm going to go ahead and push the equal to negative 11 over, so I have that spot where I'm going to fill in the number. Go with step 2. We're going to take our b number, the 4, we're going to cut it in half. That's equal to 2. We're going to take that number, we're going to square it. 2 squared is 4. So there it is. That's the number that's going to go in the empty space there, and we're also going to add it over to the right side with that green negative 11. Clean up what we have so far. So we got now x squared plus 4x plus 4. Negative 11 plus 4 is negative 7. Stick with step 3 of using the AC method. Now, can we find two numbers that multiply to give us 4, but if we add them up, we're going to get 4. And the two numbers you should be thinking of are 2 and 2. There are the two numbers that we will replace the middle with. We have x squared plus 2x again, plus 4. Go ahead and again look at grouping. What does x squared and 2x have in common? That's an x. We're grouping those up. So that leaves us with x plus 2 in the parentheses. Look at the last two terms. 2x plus 4 has a positive 2 in common. Again, that leaves us with x plus 2. And that's, again, all happening while we're equal to negative 7. Go ahead and make our two factors. We get x plus 2 times another x plus 2. Once again, we have two factors that are exactly the same, so we can rewrite it as x plus 2 quantity squared equal to negative 7. which leads us right into using the square root property. We want to square root both sides to get rid of the exponent. But however, we're taking the square root of a negative number on the right side. And if you remember, anytime we square root a negative number, we're getting into the complex imaginary world. So we have to take out the negative sign with the I. Don't forget the plus minus symbol. And if we want to get the x by itself, we need to subtract the 2 over, getting us to a solution that we'll say x is equal to negative 2 plus or minus I root 7. Again, that means negative 2 plus I root 7 is a solution, and negative 2 minus I root 7 is a solution. There are 2 solutions to this quadratic. Okay, one last example that we're going to look at is x squared plus 4x minus 12. Now, before I get started on this, I want to point out maybe some patterns that we have not really talked about, but I hope that you could recognize going through these examples really quickly. And one of the reasons why I wrote some of these numbers in colors is that in our factor here, I had a 2 here. And if you go back up and look at step 2, when we did 4 divided by 2, we got 2 in there. Those numbers are connected. If we go back up and look at the example up here, the number in our factor was a 4. And when we divided 8 by 2 up here, we got 4. As it turns out, we'll notice that that number will always end up being the number that's in our factors. So we might say, can we skip some of those steps here with the AC method if we're comfortable with this? For sure, definitely. If we can save some steps, because you'll notice that we're doing quite a bit of writing here. Can we eliminate some writing to help us get to the answer faster? And we're going to do that on this example. So, going with step 1. We want to move that 12 over. It's negative on the left side, so we have to add it over to get positive 12. Step 2. Take the B number, 4, cut it in half. We're going to get 2. Take that result, and we're going to square it. We get 4, which means that we're going to put 4 on the left and the right side. But as I said, this number right here is going to end up being our number in our factors. So we can go ahead and jump straight to the factors here. X plus 2 to the second power. And where did the 16 come from? If we look back up here, 12 plus 4 is 16. And then we can jump down to step 4 by doing the square root property. The square root will end up canceling out the square. And again, this is a nice problem because we're taking the square root of an actual perfect square number. So we can say x plus 2 is equal to plus or minus 4. The plus minus means that x plus 2 could be equal to positive 2 or positive 4, but it also means x plus 2 could end up being negative 4. And we want to solve both of those equations because both of them are going to end up being solutions. So on the left side, subtract 2 over, and we get x equals 2. For the other solution that's equal to negative 4, when we subtract it over, we get negative 6. So positive 2 and negative 6 are our solutions for this quadratic. So the last thing I'd like to talk about this, what are some of the downfalls to completing the square? Completing the square works out really, really nice when the B number, that number that we're dividing by 2 in step 2, is even, but it's not quite so nice when it's odd. Everything divides out evenly, we get a really nice integer when the numbers are even, but if it's odd, we're going to end up dealing with fractions and we're dealing with decimals, and I know how much you guys love fractions. So in that case, if that number is odd, maybe I could resort to some other method, and that's kind of where we're going with this in this little history lesson with quadratics, is that we had factoring. There were some problems that didn't factor, then we kind of discovered completing the square, and then eventually we can lead into the most infamous formula, and I'll save that for you in our next video. So here's how to do completing the square when your leading coefficient is 1.